Alright, welcome back year 11s. I was hoping that this video will be the last one, but let's see how it goes. Alright, so we continue from 5a and 5b. I'm just going to skip 5c. Let's go straight to functions. So a function is a f of x, or the y coordinate is an expression in terms of x, and we're going to look at a one-to-one functions. So what it means by one-to-one, for one x will correspond one y. So technically it is it will happen to be if different x values map to different y values. Another way to describe that is if you have two values that are different, a and b, it implies the respective function of a and b will also be different. For any values of a and b, that will be elements of the domain of that function, or the implied domain. We'll see also, which is probably the most visual way, well, it's the visual way to do that, is to do a horizontal line test. Okay, so which of the following functions is a one-to-one? We'll introduce this with a pair of values, and as you scan it, look at the y coordinates. So let's go through the solution. With the y coordinates, you can see there's a 4 that is identical, but the x are different. Therefore, the first set is not a one-to-one. The next one, the x coordinates are 1, 2, 3, 4, and the respective y coordinates are 4, 3, 2, 1, which are different. Therefore, we can conclude that that set is a one-to-one. With the horizontal line test, so what you do is it can be drawn anywhere on the graph, and as long as at any position it only ever intersects the graph at maximum once, then the function is a one-to-one. So it's usually, you will use that the other way around. If you intersect the graph more than once, then you can exclude that function as a one-to-one. Alright, so let's look at this one. Let me use that pen just to show you how it works out. So I do a line test here. It doesn't have to be, obviously if I do a line test here, it doesn't intersect the graph, but you can do it over here, intersect twice, so not a one-to-one. So we cross that off. Straight line, you intersect horizontally. It intersects only once, so it's a one-to-one. Obviously red is not the right color here. With this one, horizontal line test, you would do it here, which would not intersect, but if you just overlap here, you can see you will have an infinity number of intersections. So this one again is not a one-to-one. Here only once, so it's a one-to-one. Half a circle, if I cross over here, I get my straight line, not really, but intersects twice, so it's not a one-to-one. Alright, last bit with 5D, implied domains. We've seen that previously. So the implied or maximal domain of a function is the set of all real numbers. With those numbers is usually related to the x variable for which the rule of the function has meaning. So that x variable, which is our independent variable, or the variable on the horizontal axis, here it's a polynomial or quadratic. The implied domain is going to be R. For square root, you look at inside the square root, x has to be greater or equal to 0. So when you have x greater or equal to 0, we can also write the domain as an interval from 0 included to positive infinity. So let's look at that, an example. State the implied domain, sketch the graph, and find a corresponding range. So with the first function, you have a square root. It will be defined as long as the 2x minus 5 is greater than 0. That will help you to find the domain. You should have seen also with a little bit of transformation, when is it equals 0 is for x equals 5 over 2. So you can do this sketch first. You're starting from 5 over 2 and you draw a sort of a square root shape. To find the implied domain, you solve that inequation. 2x minus 5 is greater or equal to 0. And as x has to be greater than 5 over 2, here's your implied domain as an interval. And for the range, you will go from 0 to positive infinity. So that will be that last notation for that interval. Here the way they would have done that is r plus is all the positive numbers with the union of 0 that will summarize to that interval. With the second one, g of x, so it's a hyperbola 1 over 2x minus 5. You can have your vertical asymptote is when the denominator is equal 0, so it's for x equals 5 over 2. Notice also you have a horizontal asymptote when x is very large. The curve is getting close to the x-axis, and when x is towards negative infinity, the red curve is getting close to the x-axis from below. To determine the implied domain, so x has to be different or not equal from 5 over 2, so the implied domain is r excluded or backslash 5 over 2. And looking at the scanning the sketch, you can see the y values will be r excluded 0, so that's the way it will be annotated down here. And that's it for 5D, and I'll see you next time.